Hi everyone. In this exercise, I want to show you another example of a tractor field using a different type of grid. For this one, we are actually going to use a rectangular grid, but you can also try to use a triangular or a square grid for this exercise. I'm sure you're going to actually get different results for either of those. So the rectangular grid is basically works with grid sizes and number of grid cells. So what we have to do is specify some sort of intervals for these. And I'm also going to show you a trick. If you want to set up, let's say, an integer slider, you can do this quick shortcut. If you do 1.30, you will automatically get a slider between 1 and 30. And that's kind of a shortcut to control the customization for the sliders. So I'm going to actually do let's actually work on this in the top view. I want to do an aspect ratio that is in the landscape format. And I also want to do horizontal grids. So let's also specify 1.5 and play around with the cell sizes or the ratios. So I want these to be 2 units vertical, and let's make them 4 units horizontal. So those are going to be the ratios I'm going to be playing with. You can also do 1 to 2, which will be exactly the same, or you can do 1 to 3. Let's actually stick to 1 to 3. And I also want to increase the number of vertical cells because our cell count in the vertical dimension is actually less because the ratio is less. So now that we have the cells, what I want to do is do a play of scaling these cells. So in the last attractor exercise, I actually showed you scaling units using a scale function and using point attractors. But this time I'm actually going to randomize the scaling and going to just scale all the cells in a uniform way, but pull them to a different quadrant. So I'm going to quickly sketch out what I want to do here. So let's turn on the grid snap. Let's assume this is our cell. And let's say that these are its corner points. So we have 4 corner points. So what I want to do is scale this cell, or create a scaled version of this cell geometry to one of these corners as the scaling center. So what I mean by that is, let's say we run the scale function, and I want to select this corner point and type in 0.7, and let's also make it copied. So if I do 0.7, you can see that this is now the scaled copy and this is the center. But if I do, let's say, the bottom right corner the same way, this is what I get. So I want to actually scale them the same amount, but I want to choose different corners for each of these cells. So I want to randomize the corner selection. So for this exercise, we're actually not going to use attractors. It's just we're going to play with the data, and we're going to access the data using lists. So we can start with the cells, and we can actually just flatten them out into a single list, so that we have at the moment over 500 cell geometries. And what I want to do is first explode these cells, and by exploding it, explode is located under curve utilities explode. So once you've supply this, you will get line segments and vertices. So let's actually do this in one single cell. So I'm going to access, type in list item, and access the first item in the list, which is this bottom left cell here. I'm going to temporarily hide the grid, and let's actually operate on this. So I'm just getting rid of 570 curves and just accessing the first item in that list, which is this rectangle here, so that I can visualize parametrically what I intend to do on this example. So once we explode this geometry, we get 4 line segments and 5 vertices. We get 5 vertices because it's a polyline that connects to its end. So we need to enter 5 points for it. You can actually keep this as 5, but we can also filter the number of points because all we need is 4 points. We just need the corners. And if you look at what the point data is looking like, you can see that the first point and the last point are identical. So technically we can actually get rid of one of them. And we can achieve this by using shift list. So shift list is located under sets, list, and shift list, which is basically where we increment the index and adjust the list. So in order to adjust the first item or the last item, I can supply 1 or -1. Keep in mind that the indices for lists start from 0 and go by integer. So let's try -1 ... as a slider, and I want to filter the vertices, and let's say I want to filter the first item and supply this. And be careful that here shift list normally comes in wrapping values, which means even though you shift the value, you would actually get the same list modified. So you can see that by shifting it by 1, I actually put the first item to the end of the list. So I get now 2 origin points. So in order to prevent that from happening, I can use Boolean toggle. Boolean toggle is basically a true or false condition. And when we turn off wrapping values, we actually get that data shifted and filtered out. So it doesn't get appended to the end of the list, it just gets removed. So if I shift the list by 1, you can see that the first item is now gone. So I'm adjusting the index to start to the first index. So the list starts from the second item. And this is the result that we get. But if I do the reverse, if I do -1, you can see that the last item is shifted. Now we are starting from 0, 1, 2, 3, and the 4th item is filtered. So this is the list's condition before we do the shift operation. Either of these would work. Actually, you can do -1 or +1. I would just recommend to use the toggle to be false. Now the next step is basically after we shifted the lists, I want to access one of these items. So if I do list item, I can get an index from 0 to 3. So the 0 would give me the first value, which is the origin. The first index is this point right here. Second point is here, and third point is here. Keep in mind we filtered the last point, which was also the origin. So I want to somehow randomize this index generation for all these cells, and I want to scale the geometry here to one of these corners. So basically what I want to do is scale this geometry here to one of these corner points that I get. And the scaling factor could be some numeric value between 0 and 1. And let's make it 0.6, for instance. I can type in 0.6. So that's the value I get. And this is the result that I have. And if I change this index here, you can see that the scale function is consistent, but the location where this geometry is pulled is changed. And what I want to do is actually multiply this operation for all of these cells, but somehow grab a different index for all of them. So in order to do that, I need to basically get rid of this list item here and operate on all of the curves and supply the right amount of indices per item. So if I were to supply this curve here by itself, you can see that, let's actually see what's going to happen. Once we do shift list, we actually get the indices, and these are single points, but this data is grafted here. I can actually flatten this out as well so that we match the data here. The data structure should be identical. if I were to flatten here, you can see that the same operation has been applied to all of these cells, but there is no randomization happening at the moment. So all of the cells now use the third index, and I can also play around with the index, but they're just changing it the same way. So what I want to do is use a different index for all of these points. And my possible indices range from 0 to 3. So what I want to do is generate a random number from 0 to 3. And I can use the random generator to achieve that. So if you look at random is located under set sequence. We actually looked at a bunch of these tools before. We looked at range and sequence, for instance, to generate numbers. But what's different in random is that you actually use a seed, a number of random values, and a domain to generate some values. For instance, let's actually look at the inputs. Right now the number is, I think, set to 1 if I were to supply 20. And the domain is right now between 0 and 1. This random generator is basically giving me 20 random values between the interval of 0 and 1. And if you want different random values, you can just change the seed value and your random values would actually be recalculated. In our case, though, we need the random values to be between 0 and 3. There are a bunch of ways we can convert this, but the easiest way would be to actually generate random values between, let's say, 0 and 4, and then turn them to integers. Random values are not by default generated as integers, but we can convert floating values to integers. So I can construct a new domain here and supply 0 and 4 as my interval. If we supply 3, I think we will get values that are less than 3, and we will never get index 3 in our random generator. So if you look like this, for instance, we get 2.92 generated. But when we convert this list to an integer list and look at how they get how the data is transformed, it actually does a pretty good job. So this actually rounded it up. In some program languages, normally this gets floored, which means 2.92 gets converted to 2, but not in our case. It actually got 3 generated for values that are, I think, above 2.5. So this is actually an interval between 0 and 3 is all that we need. But we are missing one more thing, which is that we need to generate one random value per geometry. So in our case, we have 570 cells. So we need to get the amount of items. So we have 570 items, and we can get the total count using list length. List length is located under set list. And list length, it basically gives the number of items in a list. So we need to generate 570 random values that are between 0 and 3. So these are my values now. And let's see what happens when I supply this to my shift list. But we need to be careful here, because if you look at the explode function actually generates a list for all of these curves, because it needs to output the vertices per curves. So we get 5 corner points, and then we are shifting the list into 4, but we are still having dealing with lists here. So in order to match this data type here, we need to graft the int container here, so the integer container. So if I graph this, now you can see that the data stream here is kind of matched, because this is now all the items are put into a single list. And now if I supply this, you can see all of them receive a different integer value. So I'm going to turn off some of these values. These are the center points that are chosen for scaling. And this is the result that I got. And you can see that all of them are using the same scale function. And the last operation is basically to connect them into a surface. So what we could do is I can merge the scaled version with the unscaled version per cell, and to put them into containers of 2, we can just graft these inputs here. What that does is it basically couples each item in these lists and puts them in a single list. So if I loft these now, you can see that we will get these surfaces formed. So these are the surfaces that are generated per cell. We can also give them some height value. For instance, if I were to move to the 3 dimensions, after we had done the scaling, we can actually move these vertically. For instance, I can move them in the z direction, in the vertical direction, by some negative amount. Let's say minus 3 dot dot minus 10. Actually, do this minus 1 dot dot minus 10. It didn't actually register power, but we have to start with minus 10 and go to negative 1. And if I were to first dislocate, like relocate these to the bottom a little bit, I think 2 is too much, but let's actually edit the lower threshold to be 5, and let's actually add some digits to this so that we can actually let's actually make this 0, and we can actually control the height value here. And if I replace these, you can see that these are actually 3-dimensional. These can be 3-dimensional geometries. Now, before I end this exercise, there are a bunch of other things we can add to this. For instance, we can control the amount we want to use for displacement, or we can change the we can randomize the factoring amount as well. For instance, I can simply generate a second random generator here that basically takes similar inputs. So I'll make a copy here. But this one will generate values between 0 and 1. And I need to make sure that it won't generate a value, let's say, between, if it generates a 0, that will be a problem, because then we won't have any geometry there, because if we scale something to be 0, then it won't be a geometry. So I can set this to be something specific. For instance, 0.1 could be our lower threshold, and the higher threshold could be 0.9. Let's see if I can make that happen. So let's make this 0.9. So now the random values we get would always be between these 2 intervals, and I can supply this as the scaling factor. So this is already in a single list, and here we have items coming in. So if I were to replace the single item here, we get all these values. Now let's see what's happening. Some of these are actually not connected, but let's see if we have an issue here. So we are moving them as well. So let's look at it in 3D. And we are moving them. And we should be able to loft them actually, but let's see what's happening in loft. One of these is, I think, not working the way we want it to work. So let's actually replace this for now and see if it works. Once we graft it, it actually doesn't match these 2 datas, because I think by transforming them, it actually adds some more data structure to the grafting. I actually don't want to confuse you, but if you right click here and do simplify these trees, I think that will solve our issue, and that will only create a data stream matching each other. So we don't want additional data streams coming in. So simplification basically seems to cure this issue. And you can see now we actually got this type of wall configuration here, which is a really simple script actually generating kind of a novel effect. And we can also play around with the seeds here if we want to basically change where we want to scale or how much we want to scale. For instance, if I enter a different seed value here, the whole wall configuration would change. And I can also change here the scaling direction. And you can create a lot of variations with this. You can also try maybe generating another random value for the vertical displacement of these scaled geometries. So let's actually look at what we get. And I'm going to bake all of these, move them down. So there you have it. This is the three-dimensional look of that surface, and you can see that some of these cells have pretty novel geometries inside of them. Some of them do repeat, but most of them are kind of unique, and they all have different types of apertures, which is really interesting. So I hope you like this exercise. This is actually a great exercise to get to understand lists, data, and how we can actually use the random generator to access different indices of values in lists. And we were able to randomize this type of cell configuration and generate a random wall surface like this. So I hope this was kind of an interesting example for you to look at. And I'll see you guys in another video.